Hello, I am Paul Dean, a research associate at Lancaster University, and today we're presenting our work as a part of the AI4ME project, a partnership between Lancaster University, the University of Surrey, and the BBC. Our work looks at exploring the autonomous compute migration and cache reusability. What this means is that we can autonomously migrate compute from a client locally to remote services, and cache reusability looks at achieving sublinear scaling to reduce this cost. In a moment, you will see clients connecting to our servers hosted remotely in Lancaster University, with our current location being Manchester, as these perform the operations of rendering the individual layers of our object-based media, that being the presenter, the time image, subtitles, and map. In a moment, we'll allow this remote containers to be discoverable to the clients. The clients will then dynamically inject the code required to perform network communication at runtime, and will then begin to search the available resource containers, looking for the best placement choice. As we allow time image and subtitles to be discoverable to each individual client, we begin the autonomous compute migration process. We explore the available containers, we decide our placement choice, and we exploit the improved performance, in this instance our reward being the reduction in render. We then share the completed compute from an initially connecting client by caching it and allowing connecting clients in a close temporal proximity to reuse the rendered frame. This reduces the overall cost of multiple connecting clients to cloud resources, as they are not provisioning compute to perform the process, but rather sharing a previously performed result. This achieves sublinear scaling, reducing cost without affecting the client's experience, even when code and compute is offloaded. Our future work looks at exploring more complex rendering processes. While we have a weather forecasting app here, future work will look at a digital presenter or dynamic lighting. We will then be looking at addressing this problem at a much larger scale, with thousands to millions of connecting clients across differing geolocations with differing requirements on the devices, performing different workloads as compute that was required to be offloaded changes among clients. This opens up a secondary problem of understanding our placement decisions. As we now have multiple clients with different media streams, we must understand how we can best co-locate and place the offloaded compute. This has factors such as geolocation, latency, the required computation, and cost, as we must decide whether or not we provision more cloud resources, or we combine them through reducing compute. Thank you for watching this demonstration, and we look forward to showing you our future work.